Welcome to science class by Mrs. Kamal Amwani, your science teacher from Macrovision Academy, Brandpur.
Hello dear students, all is well. In our previous video, we discussed about the basic about physical and chemical changes. Also, we discussed the definition of physical change and chemical changes. We discussed few important characteristics of physical changes and chemical changes. Today we will start our session with few more new changes that are reversible and irreversible changes. What are reversible and irreversible changes? The changes that can be brought back, that can be brought back by reversing the condition, by reversing the conditions. What it means? When we have to freeze the water, means we are reducing the temperature. We are taking the water from the higher temperature to lower temperature. But when we have to get the water out of ice, again we are increasing the temperature. Means we are reversing the condition to get the product back. So this is a reversible change. Then irreversible. We discussed many examples of irreversible changes also in physical and chemical. But why they are irreversible? Because we do not get the original substance back. For example, milk. When we prepare curd from milk, is it possible to get the milk back from the curd? No. If I will reverse the condition, then also it's not possible. So this is a reversible change. And at the same time, one more example, burning of any substance. After burning, substance gives heat, that is the energy, or maybe the energy will be in the form of sound or light. And also sometimes burning of material gives ash or smoke or gaseous mixture. So means the chemical is completely changed. Now which cannot be brought back into the original one. So this is an irreversible change. So after discussing this irreversible change and reversible changes, let us discuss few important points about the chemical changes once again. Chemical changes, when they take place, there may be some indication that chemical change has taken place. What are that indication? Already we discussed a few of them, that evolution of gas or formation of effervescence. Second, what is second? That is formation of new substance. Then change in color, and also it will give out smell. Change in smell. Many more things are there where we can indicate that chemical change has taken place. We will discuss all these changes with the examples. When I say evolution of gas, here we will discuss one example, that is when the vinegar, which is also an acid, when the vinegar is mixed with baking soda, which is sodium bicarbonate. Baking soda. What will be the product? It will produce gas, that is carbon dioxide gas. So, carbon dioxide is the gas released during during the reaction of vinegar and baking soda. This gas indicates that chemical change has taken place. How we can prove that it is a carbon dioxide gas? By passing carbon dioxide through lime water. What is lime water? Calcium hydroxide. What is lime water? It is calcium hydroxide. When we pass this gas to lime water will turn milky. Lime water will turn milky. Which says that the gas produced during this reaction is carbon dioxide. And also we understood that the new substance is formed. So it is a basically chemical reaction or chemical change. Radiation or absorption of heat. Radiation or absorption of heat. In radiation means the heat is given out. Have you ever seen any change, anything which give out the heat? Yes, when we burn fuel, it give out the energy in the form of heat. So we can say it is a chemical change where the heat is radiating out from the reaction. So also when the heat is given out, so this reaction is called exothermic reaction. When the heat is given out or coming out from that reaction. So that reaction is called exothermic reaction. And when heat is absorbed by the reactants and to produce new substance, so that is called endothermic reaction. Endothermic reaction. So these are the two type of things which happens during the chemical change. Either the heat will be absorbed or radiate from the new substance is formed. Thing which takes place during the chemical change, that is the change in color. Change in color. For this, which example we can give? I am sure you all have seen iron. It is of grey color. And the grey color iron, when reacts, it turns to brown flaky substance. Brown flaky substance, which we call rust. It converts from grey to brown. What happened to the iron? Here again the chemical change has taken place, which we call rusting. Rusting is a chemical change when the iron react with oxygen and water in air. It forms iron oxide or rust we call in common. So rusting takes place where iron reacts with oxygen and also moisture in the air, and this reaction give new chemical compound, that is iron oxide, which is also called rust. Rusting is faster in humid air. Why? Because when the oxygen and water both are present in air, then the rusting is faster. So you must have seen that iron is very important element. It is very useful prevent the rusting. How to prevent the rusting? To prevent the rusting, we must do the paint on iron. We must apply the paint on iron object so that the contact must cut the contact of air with iron object. Second, again the greasing and oiling is the best option to break the contact with air. One more option is there, that is galvanization. Galvanization. Galvanization means coating iron object with molten zinc, as zinc do not get rusted in air. So we can coat iron with zinc, molten zinc, to prevent it from rusting. So that process is called galvanization. The coating of iron with zinc or chromium to prevent rusting is called galvanization. Another important method is alloying. Another important method to prevent the rusting is alloying. Alloying means mixing metals and non-metals to make them. Alloying increase the quality of the metal and which prevents the rusting. Next, as we discussed different aspect of chemical changes, few more examples are there, that is burning of magnesium ribbon. Burning of magnesium ribbon. When we burn the magnesium, magnesium reacts with oxygen and give out magnesium oxide. It gives magnesium oxide. And when it is a new substance, it is a new substance. Magnesium oxide is a new substance which we can say that it is a chemical change. And when magnesium ribbon burns, it gives out white light, which again indicates that chemical change has taken place. White bright light we can see. Then magnesium oxide added to water, it gives magnesium hydroxide. That is, we also discussed about magnesium hydroxide in our previous chapter. So you must be knowing it is a base. It is a base. So again we got new substance. So this is a chemical change which is taking place and one of the example of chemical change. One more chemical change in which the color is changing. Displacement reaction. Displacement reaction, or when the copper sulfate solution and iron metal are mixed, what will happen? Copper sulfate solution is basically blue in color. It is blue in color. When the iron is mixed, copper sulfate plus iron give out iron sulfate plus copper. When the iron sulfate is formed, it is actually greenish blue. It is greenish blue. I think this is clear. It is greenish blue. Now, this is again one more example in which the chemical change is indicated by the change in color. Next is crystallization. It is not exactly a chemical change. It is not a chemical change, but it is very important topic in which the crystals are formed. Crystallization. When the pure crystal of any substance obtained, that phenomena is called crystallization. It is a process in which we can get the pure crystal of any substance. Okay, now how to obtain the pure crystal? Preparing the crystal of copper sulfate. Take water in beaker. Then add copper sulfate powder. Then heat the mixture. Heat the mixture. Heat the mixture. Now add more copper sulfate. Add more copper sulfate. After that, you will find that the solution now is not taking any more copper sulfate, means the solution is super saturated. It is super saturated. After that, cool it. Cool the solution. Cool the mixture or solution. There should be a little amount of water left. The water gets evaporated and the remaining material is a crystals of copper sulfate. So in this way we can obtain the pure crystal of any other material also like sugar and salt. So this is all about crystallization. In this chapter we discussed so many examples of chemical changes. In this chapter, we discussed about so many examples of chemical changes. Also, we discussed about the physical changes and its example. We discussed about reversible changes and irreversible changes. I am sure all the practical aspect and concepts are clear to you and you understood everything very nicely. And if you want, you can share your doubts. Till then, take care. Have a nice day ahead.